Hi everybody, Mrs. Pesic here. You are watching summer video number 1 for Honors Algebra 2 with Trigonometry. The topic of this video is properties of exponents. And after you complete watching this video, you're going to take a Blackboard quiz. And the Blackboard quiz will have 5 questions, and you need to get at least 4 of them correct in order to move on to the next video and the next quiz. All right, each of the 4 videos has a quiz associated, and each quiz has 5 questions. You need to get at least 4 of the questions correct. Okay, so what are we talking about with properties of exponents? A lot of this is going to be a review for you from Algebra 1. So here's integer exponents. You know that a to the 4th means a times itself 4 times. And -3 with parentheses around it, raised to the 5th, would be -3 times itself 5 times. All right, that's an example of integer exponents. You also know that if I want to take 5x times itself 3 times, I could write that as 5x in parentheses raised to the 3rd. All right, we have exponential notation. If a is a real number and n is a positive integer, then a raised to the n is going to be equal to a times itself n times. So n factors all together. All right, so in general, we would write a to the n, and a would be the base, and n would be the exponent. Note, exponents can also be negative. They don't have to be just positive, and they can be fractions. All right, it can be fractional. So here are our properties of exponents. So let's review this. I know that you know these properties already, so we're just going to kind of review here a little bit. So let's start with number 1. If you have a to the m times a to the n, you know that's equal to a to the m plus n. So for example, if I have something like 5 to the 3rd times 5 to the 4th, that's going to be equal to 5 to the 3 plus 4, that's 5 to the 7th. Let's take a look at this next example. What about if we're dividing 2 numbers that have the same base? In this case, they both have base a. I'm taking a to the m over a to the n. Well, in that case, I want to subtract the exponents, and I would get a to the m minus n. So let's take, for example, if I have x to the 8th, and I'm going to divide that by x to the 2nd, I want to subtract the exponents. So that would be x to the 8 minus 2. I don't divide the exponents, I subtract. And so I would end up getting x to the 6th. All right, let's take a look at property number 3. For this property, this is a negative exponent now. So if you have a to the negative n, that's the same thing as writing 1 over that same base of a raised to the positive n. Or you could write it as 1 over a in parentheses, and that gets raised to the n. So for example, if I have something like 8 raised to the negative 3rd, that's the same as writing 1 over 8 to the positive 3rd. Let's take a look at property 4. This involves 0 as an exponent. So if you have a raised to 0, that's always going to be equal to 1, as long as a is not equal to 0. Because 0 raised to the 0 is not equal to 1. That's called an indeterminate form. We cannot really analyze those without some calculus. All right, so for a to the 0 equals 1. So for example, if I have 7 to the 0, that's just going to be equal to 1. All right, let's take a look at property number 5. So if I have a times b in parentheses raised to the m, that's the same as a to the m times b to the m. So if, for example, I have something like 9x raised to the 2nd power, that's the same as 9 to the 2nd power times x to the 2nd power. So I could write that as 9 squared times x squared. All right, which is going to get me 81x squared. Let's take a look at property number 6. This is if you're raising a power to a power. So in this case, I've got a to the n, but I'm raising that to the nth power. So what I need to do is multiply those exponents together. So I'm going to have, for example, pick up an example here. So if I have something like x to the 3rd raised to the 2nd, that's the same as x to the 3 times 2, which would be x to the 6. All right, so when you're raising a power to a power, you multiply the exponents. All right, but what if I got a fraction and I'm raising the fraction to some power like m? Well, then the numerator gets raised to the m, and the denominator gets raised to the m. So if I have 2/3 raised to the 4th, that's the same as 2 to the 4th divided by 3 to the 4th. All right, so those are our properties of exponents. We've got one more that maybe you've heard of, maybe you haven't, and that one looks like this, and it says absolute value of a squared is the same as absolute value of a with the squared on the outside, and that's equal to just a squared. Right? And this works if a is positive, it works if a is negative. So for example, if a is positive, like let's say a is 5, then absolute value of 5 squared is absolute value of 25, that's going to be 5. But that's the same thing as saying what's the absolute value of 5 and then squaring it. Well, absolute value of 5 is 5, and then 5 squared is also 25. So it works when you have a positive number for a. What about if I have a negative number for a? Like let's say I had -3 as my a. If a is equal to -3, then here I've got -3 quantity squared, and I want the absolute value. Well, -3 times -3 is a positive 9, so I get absolute value of positive 9, which is 9. But is that the same as absolute value of -3 in parentheses squared? Well, absolute value of -3 is 3, and then I still need 3 squared, so that is also equal to 9. So it does work. It is equal to 3 squared. All right, so that brings us to this question. Is -2 in parentheses raised to the 4th the same as opposite of 2 to the 4th? So are the parentheses even necessary? Well, let's talk about that. Actually, they are necessary. You could try this with your calculator both ways and see if you get the same thing. This side really means -2 times -2 times -2 times -2, which is going to end up being a positive 16. This side here really means opposite of 2 times 2 times 2 times 2. So this part here is 16, but I still have this negative in front, so it's equal to -16. And that means 16 not equal to -16. That's weird symbol. That's supposed to be a not equal to symbol. So 16 is not equal to -16. So those parentheses make a difference. They are important. So please know when you need a parentheses and when you don't, and what they mean and how to evaluate them. All right, let's take a look at some examples here. If I want to simplify 4x squared y raised to the 3rd, we're going to use one of the properties we just talked about, which means that everything in this parentheses, they're all being multiplied together, each one of them has to be raised to the 3rd power. So I need 4 to the 3rd times x to the 2nd raised to the 3rd times y raised to the 3rd. So that's going to get me 4 to the 3rd is 64, x to the 2nd raised to the 3rd. I need to multiply these guys, so that's going to be x to the 6th and y to the 3rd. So this would be my answer for this problem. Let's take a look at letter B. All right, next example. And for this one, let's slide this down a little bit. I've got lots of examples here. Let's try this one. In this case, I am multiplying two quantities together. So I'm going to multiply the 5 times the 3 and get 15. I'm going to multiply the w squared times the w. Really, I don't see an exponent here, so it's understood to be a 1. So if I'm multiplying w squared times w to the 1st, what do I do with the exponents? I get to add them, so I'm going to get w to the 3rd. So my next is w to the 3rd, and then what about this next one? I've got y to the 3rd and y to the 6th that I'm multiplying. Well, y to the 3rd times y to the 6th, I'm multiplying two numbers that have the same base, so that means I need to add the exponents. So that's going to be y to the 3 plus 6. So I get y to the 9. And then this would be my answer for letter B. All right, let's take a look at our next example. Okay, so for this next example, we're looking at 4a to the 0 over 5b cubed. and we're taking the whole thing and we're squaring the whole thing. So in this case, I would rewrite this. Well, first of all, a to the 0 is equal to what? Well, anything to the 0 is equal to 1, as long as a is not equal to 0. So that's just equal to 1. So far I have 4 times 1 in the numerator over 5b cubed, but the whole thing has to be raised to the second power. So I think here I would do 4 has to be squared, and 5b cubed, that whole thing has to be squared. So I'm going to have 16 in my numerator. The 5 has to be squared here, so that's going to be 25. And the b cubed has to be squared. That means I need to multiply my exponents together. So I think this would be my answer here. I don't think I can divide anything out. I think that's it. Let's try this next example. For this one, we're doing 5w quantity to the third times 10y raised to the negative second. Well, first of all, I see this negative 2 here. Now, you know that the negative exponent means 1 over the same base to the positive exponent. So I could write this as 5w cubed times 1 over 10y raised to the, how about 1 over 10y raised to the positive second. So this is really, think of that as over 1. So that's going to get me, over here, I'm going to have 5 has to be raised to the third, and w needs to be raised to the third. So it's 5 to the third, w to the third, over 10 has to be squared, and y has to be squared. So my final answer is going to be 125 w cubed over 100 y squared. All right, let's take a look at the next example. 1 over 5x raised to the negative third. Now, this one, interesting to ask, I think, is this negative 3 the exponent on x, or is it the exponent on 5x? Well, I don't see a parentheses, so that means the negative 3 is only an exponent on the x, not on the 5. So that means that's the same as 1 over 5 times x to the negative third, but x to the negative third is the same as 1 over x to the positive third. That means I really have 1 over, and I can think of this as a 5 over 1, multiply my numerators, multiply my denominators, so I get 1 over 5 over x cubed. Now I'm dividing by a fraction, so it's the same as multiplying by the reciprocal, so that's going to be 1 times x cubed over 5, so I'm going to get x cubed over 5. All right. You could notice that I only have x raised to the negative third. I could have just brought that up to the numerator with a positive exponent. So I could have immediately written x to the positive 3 over 5, and that was my answer. All right, let's take a look at this example. For this one, I've got 25x to the second, y to the negative third, over 15x to the negative fifth, y to the negative first. Anything with a negative exponent, like right here, could be moved to the other part of the fraction with a positive exponent. So that means I can get rid of the y to the negative third, because it's 1 over y to the positive third. So I can rewrite it in the denominator as y to the third. I have x to the negative fifth here, but I don't want that negative, right? We don't ever want to leave our final answer with negative exponents. So I'm going to put that up in the numerator with a positive 5 exponent. And I've got one more of those. I've got y to the negative first in the denominator, so I'm going to move that up to the numerator and make it y to the positive first. So far I still have the 25. I've got x to the fifth times x to the second, and I have the y to the first in the numerator. In my denominator, I have 15. This one's gone. I moved that one already. I moved this one already. But the y to the third moved down to the denominator. At this point, I notice that I'm multiplying these two numbers that have the same base. So I can add the exponents. So I'm going to have 25x to the 7, y to the first, or I'll just write y, over 15 y to the third. It's okay for us to divide out the 15 and the 25. 5 goes into that 3 times. 5 goes into that 25 5 times. So now I have Let's see, I've got 5x to the 7th y over 3y to the 3rd. Notice that I am dividing two numbers that have the same base, y in the numerator and y to the 3rd in the denominator, and that's got an exponent of 1, and I know I need to subtract. So I'm going to write this as 5x to the 7th, y to the 1 minus 3, right, because I subtracted this exponent of 1 minus this exponent of 3 over 3. And so I'm going to have 5x to the 7th, y to the negative 2 over 3. But we don't want to leave that as our final answer because we don't want any negative exponents in our final answer. So we're going to move this guy down to the denominator and make it y to the positive second. So our answer should be 5x to the 7th over 3y to the 2nd. That would be our final answer for this problem. All right, let's take a look at this one for letter G. Let's see, in this example, we are simplifying 6x squared over 9y squared times 4y to the 5th over 10x to the 7th. You're multiplying two fractions, so I would just multiply my numerators together and then multiply my denominators together. In multiplying my numerators, I got 6 times the 4 is 24, and I've got x to the 2nd times y to the 5th. All right, and then here, and if I multiply my denominators together, 9 times 10 is 90, and I've got an x to the 7th and a y to the 2nd. All right, now I see that I can divide out 24 and 90. I think 4 goes into each of those. 4 goes into 24 6 times. 4 goes into 90. Maybe not. Maybe I better stick with 2. Let's try this. If I go 2, 2 goes into 24 12 times, and 2 goes into 90 45 times. But I think 3 goes into both of those, so 3 goes into this 4 times, 3 goes into this 15 times. I think I've reduced that as much as I can. So I've got 4 in the numerator and 15 in the denominator. Notice, though, I have x to the 2nd over x to the 7th. That means I want to subtract my exponents. And remember, that always goes in the numerator. So it's going to be x to the 2 minus 7. Think of that as over 1. And same thing here. I've got y to the 5th over y to the 2nd. So I'm going to do y to the 5 minus 2 in the numerator. That's over 1. All right, so what do I have now? I've got 4 over 15. I've got x to the negative 5th. And I've got y to the 3rd. So here, x to the 5th is really over 1, y to the 3rd is over 1, but I'm going to want to bring this one down to the denominator and make it an x to the positive 5th. So I've got 4 over 15 times 1 over x to the 5th times y to the 3rd over 1. And so multiplying my numerators together, I get 4y to the 3rd. Multiplying my denominators together, I get 15x to the 5th. And that's going to be my answer for that one. Okay, on some questions on the quiz, you will be asked to enter the numerator separately from the denominator. So I want you to practice so you know what that's about when you see this question, these questions on the quiz. So if you reduced your rational expression and you got 5x squared over 4y to the 3rd, you're going to enter the numerator as 5x raised to the 2nd, just like you see here. Don't put any spaces in. Don't try and put in a multiplication dot or anything like that. You're going to do 5x with this little caret sign and then a 2. That little caret sign means raised to the power. So it's really 5 times x raised to the 2nd. Don't do anything other than what you see right there. Your denominator, you would enter 4. You would enter that as 4y caret 3 for 4y to the 3rd. So if your denominator looks like this, you're going to enter this on your calculator. Do not use spaces or any other symbols. Okay, so here are 5 extra practice problems, and I know that this is going to take you a little while to work out. So I want you to pause this video, try these problems, and then you get to check your answers on the next page. So so pause the video, try the problems, then start the video up again and see what the answers are on the next page. Did you pause the video yet? Are you working on these problems? Okay, hopefully you had a chance to try every one of these problems, and let's see what the correct answers are for these problems. All right, for number 1, should have negative 80. For number 2, 128 w to the 7th. Number 3 should be y to the 4th over 3. Number 4 should be 1 over 2x cubed. And number 5 should be 9r to the 6th over 20p. All right, so that's it for this video. If you were successful with these practice problems, then hopefully you're feeling confident on taking the quiz. You need to get, there's going to be 5 questions. You need to get at least 4 of them correct in order to say you have passed this, this quiz. All right, if you're having any issues or problems with any of the problems or answers that I have on this video or with the questions on the quiz, please let me know. I don't want there to be any errors, and I don't want you to be confused. So send me an email, and I can look into whatever the issue is. All right, that's it for this video. Thanks for watching, and hopefully you're ready to take the quiz.